Chapter 2, 109. A 7.36 gram sample of copper is contaminated with an additional 0.51 grams of zinc. Suppose an atomic mass measurement was performed on this sample. What would the measured atomic mass be? Okay, so 7.36 grams of copper. I was going to write this stuff down here. 6 grams of copper. That is a U. And that has been contaminated with 0.51 grams of zinc. All right. And the question is asking us for the formula weight of this whole alloy thing here. What is that equal to? So the way to do this is to get a percent molar constitution of this alloy and use the percentages of both copper and zinc present in it to scale their molecular weights, right? And that expression looks sort of like this. I'm just going to write it. I'll write it and I'll erase it, but it's good to know where we're headed with this. Formula weights are always equal to like X amount of moles of this, in this case, all right, plus Y moles of zinc, all right? And formula weight wise, that turns into this. So you have X moles of copper times the formula weight of copper, all right, plus Y moles of zinc. Zinc times the formula weight of zinc. Sorry for the terrible writing, but and then this would give you the formula weight of this whole compound here. Formula weight of the copper and the zinc together. So this is where we're headed here, but we need the moles that are comprised of both of them here. Fortunately, we've been given the masses of each of the elements separately, so this is a simple formality of just dividing these by the appropriate molecular weights of both these elements. So let's get the moles of copper first. So moles of copper. All right, and I'll try and write better now. This is going to be the mass of the copper divided by the formula weight of copper, which is 63.55 grams per mole. All right, and that gives us 0.116 moles. All right, there's number one done. Okay, now moles of zinc. All right, and we're doing exactly the same thing. 0.51 grams, right? That's our given mass. And we divide that by the formula weight of zinc. This one is 65.38. 38 grams per mole. All right, and this gives us we'll write this scientific. 7.80 times 10 to the negative 3 moles. 10 to the negative 3 moles. Okay. So now that we have both the moles, right, we can add these two together and we can get our total amount of moles, and then we can calculate our percent mole compositions. So moles of copper plus moles of zinc. Plus moles of zinc. All right, and this is 0.116 plus 7.80 times 10 to the negative 3. And that gives us, 2 seconds here, 116 plus 8. All right, and we'll write it out with all of its digits. 1, 2, 3, 8. All right, awesome. So there's our mole total. We're going to stick that up here, and I'm going to erase. So moles total equals 0.1238. Okay, 2 seconds for the eraser. Yeah, that's right. I got to leave those up there too. Okay, let's get our mole percentages, and then we'll make some more. Okay, percent moles of copper. So this is going to be the moles of copper over top of the total moles. All right, so moles of copper is 0.116 moles. And we divide that by our mole total. 0.1238 moles. We're not going to multiply this by 100 because I want this as a decimal figure to multiply the formula weights by. All right, so this percentage is maybe a little misleading, but all we're doing is not multiplying by 100. And this gives us 0.937. 937. Okay, so now that we've calculated this one, because, percentages are out of 100, right? But we haven't multiplied this by 100, so it's out of 1. That means that the percent moles of zinc is going to be 1 minus the percent moles of copper here. So we might take 0.937 away from that. That leaves us with 0.063. All right. Okay, so percent of zinc, moles of zinc equals 0.063, and of copper is 0.937. Okay. All right, let's get rid of this stuff, and we will finish this thing off. Okay, so our formula weight of this whole thing now is the amount of the mole percentage of each of them multiplied by the formula weights of each. So it goes formula weight of we never called this anything, so we'll call this the total. So this is going to be percent moles of copper times the formula weight of copper. And we add to that the exact same thing with zinc. Percent moles of zinc times the formula weight of zinc. There we go. Okay, let's plug in some numbers. All right, so this is, copper was 0.937. All right, so 37 moles, because we'll write this out full. Moles, and this is 63.55 grams per mole. And there's that one. And same thing with zinc. Zinc is 0.063 moles times, and this was 65.38 grams per mole. All right, so we can see here moles are going to cancel out of both of these. We're going to be left with something in grams. Oh, no, we're not. We divided this. Yeah, never mind. Sorry. That's not right at all. Moles are not canceling. We're just going to, moles shouldn't even be written here at all. Sorry, y'all. My mistake. Should definitely be getting a result in grams per mole. So that was a mistake on my part. Okay, finish it with no more mistakes. 0.937 times 6355. And I'm just going to do all this in one step. This is 63.665 grams per mole. Okay, now when we got given the masses here, we had two of them, two figures up here. So this is going to be accurate to that. So 63.7 grams per mole. And there we go.